All right. Are you ready for our first, first flipped lesson of the year? Okay. Flip lesson. Yay. I'm excited. Tomorrow we'll do a double note check. All right. Or not double note check, but a double homework check, actually. Hey, don't forget about this big day coming up 2 weeks from today. All right. Big test. Holy buckets. Thursday in class, we'll have some time to work on your projects. Uh, we will have a little brief lesson at the beginning, and then you'll have the rest of the period to do that. Remember, your projects are due at the end of the period on Friday. Here we go. Are you ready? I'm excited. Let's go. Let's talk to it. So, Unit 1, Day 8-1. My name, Mr. McConey. Here we go. Um, Today we're going to talk about linear velocity. Yesterday we discussed angular velocity. What is that? What is this? Yeah, that's right. Don't forget it. There we go. Okay, well, that was different. So let's roll with it. Oh boy, we're back and we're back. Um, so yesterday we did angular velocity. Today we're doing linear velocity. Okay. Big difference in linear velocity. Linear is something measured using, or that can be measured using a line or ruler. So something that can be measured using a line or ruler. It's feet per second. Okay, what it usually is it's a distance divided by the amount of time. Miles per hour, like in your car, miles per hour. Okay. Um, what else? What else? Feet per second. Okay, nautical miles, things of that nature. All right. Let's look back at our car guy from yesterday, our guy driving the car. So if you recall from yesterday, if you remember yesterday, we talked about the angular velocity in regard to a car. That angular velocity was represented by the speed that the wheels spin. So the difference, linear velocity, is the speed going forward. How fast you are traveling moving forward. How fast you are traveling moving backwards as well. Okay. So what are our formulas? So there are three different formulas that you can use to find linear velocity. All right, we are only going to talk about one today. All right, I'm going to write down the one that we are going to use to find linear velocity. We write that as V equals R times RW, where W yesterday, well, it's not, excuse me, or this was, remember from yesterday, that was our angular velocity. Okay, that was our angular velocity from yesterday. And this, now we have to take into account the radius, or r is still your radius. All right, so let's flip to the back. Here we go. Our first example, or we can go back there, check it out if you need that again. R is the radius, so V equals R times W, where R is your radius and W is your angular velocity. All right, example one. The tire of our truck has a radius, so our truck is back again. The tire of our truck has a radius of 15 inches and rotates at 120 revolutions per minute. So remember yesterday we talked about revolutions per minute and how we had to convert that into radians. All right, the same rule applies here. So our first step is going to be to find W. Well, that is what we were doing yesterday. So to do that, we have to convert it 120 revolutions per minute times what just happened there. All right, times 2 pi radians per 1 rev. Remember, now a lot of us are picked up on the trick that I just multiply the number by 2, which will give me 240 pi. All right, so to find our linear velocity today, we're just adding an extra step. We're adding an extra step. We're taking this 240 here. Okay, we're taking that 240 and we're multiplying it by our radius. So V equals our radius, which is 15 inches, times our W, which is 240 pi. Okay. Now, you can multiply 240 times 15 and leave it like that. All right. Well, that would get you 3,600 pi. Or I'll allow you for linear velocity to actually multiply the pi out so you can plug it all in your calculator. 15 times 240 times pi and get 11,000, about 11,309.73. 11,309.73, and that'll be inches per minute. Inches per minute there. All right. Sorry, I kind of didn't give myself enough space on these ones. That one stinks. Hey now, our penny farthing bike, those fun bikes from yesterday, remember those? My face is kind of in the way. But those are back again. All right. The big tire, the penny farthing. What are the penny farthings? Maybe watch those funny videos. That was fun. Those are so fun. Oh boy, was fun. Okay, so remember we want to, it says it rotates at a rate of 50 revolutions per minute, okay, and has a radius of 5 feet. So again, our first step here is going to be to take this 50 revs and convert it into radians. 50 times 2 pi, that's 100 pi. All right. Now just multiply that by a radius. So V equals 5 times 100. And I'm writing on a slant so I can fit this in my actual picture here. So 5 times 100 is 500 pi. And that's about 1570 feet per second. It'd be 1571 if you round it up. All right, 1571 feet per second. Similarly, we got to do our small tire. Okay, can't forget about the small tire. All right, so our 35 revs per minute times 2 pi radians per 1 rev. Okay, remember our revolutions cancel, our revolutions canceled here, revolutions canceled here. All right, so you have 70 pi. So we take that 70 pi and just multiply it. Oh, wow, that's different. Not the worst thing in the world. We take our 70 pi, hey now, there it is. And we multiply it by our radius, so 1.5 times 70 pi. And what do you get? 1.5 times 70, you get 105 pi, which is 329.87 feet per second. 7. All right. And that is it. Okay, we'll talk about this last question. Uh-oh. We can talk about this last question tomorrow in class, but that's all for the notes. Look how short that was. Remember, these notes aren't that bad. They're actually kind of fun sometimes. Even if I drew a smiley face with smiley faces. That's different. Okay? It's not that bad. All right? And this is your homework, okay? The homework pretty much lines up with what we just did in class. All right. Remember, there is a little there are a couple more review problems, and you'll see why we do that later. Okay, to convert from degrees to radians, remember. All right. Uh-oh. That's pretty cool. That's pretty neat. You need to multiply. We multiply by pi over 180 to convert from degrees to radians. All right. Hope you enjoyed that video. First one of the year. Who knows if it'll be the last. I will see you in class on Thursday.